Welcome to the Data Hall YouTube channel. In this video, we are going to understand what is the difference between RClass and EClass command. And the idea of this lecture would be to understand how do we access the information stored in different commands. So once we execute a command, it would store the results in some form, and we want to extract those results. In my previous video, I have explained what scalar and matrices are and how to extract values from a scalar or matrices. It's quite important that you go back and watch the video to understand the method, and that specific method would be used in this lecture. So let's start with the lecture. We have different types of command. One is called RScale and the second one is called EScale. EScale is the estimation class command. So for example, regression, logistic regression, etc. Those all comes under E-class. Whereas summaries, correlation, the T-stats, the T-test, or the tabulation, etc. There are a bunch of others also comes under R-class commands. So E-class commands are those that would estimate certain parameters, right? So we first start with the R-class command. So whenever we execute a command, it will store certain values in a scalar or a matrix. And the R-class command would store its value into a R scalar. So for that, let's have a data, and let me show it to you by running a summarize command. So we are executing a summarize command. We are executing summarize mileage. We know these values, right? All these values are there, but these values would somehow be stored in some backend scalar, right? They won't appear in this list, but they would be stored in the memory. If I use return list command, it would return the list of all the scalars, right? The section says scalars. It will return the list of scalars and the value that is stored in them. So we know that Rn would store, this is the label that will store 74, the value 74 from the previous estimation. This 21 was the mean value and it is stored in R mean. Similarly, the standard deviation of 5.7 is stored in RSD. And we can display these scalars or execute certain commands with these scalars. We can get these values, retrieve these values from these scalars. So let's display the maximum value. So what we are going to use, we are going to use a display command and then the name of the scalar. Remember, the maximum value is stored in Rmax because it is R-class command. So all the values would be stored in R and some label within the parentheses. So we would use this command and it displays 41. It is the exactly same maximum value that we have got from here. So remember that in Stata it is not, we are not normally concerned to display these values on the result window. What we are concerned mainly about is to perform certain analysis on them. So I'm using display command because it is easy to understand. It gives you a quick idea of what it would do, the command would do. But we can use these scalars for different bunch of purposes. So for example, I want to generate a variable. Let's call this new variable max var, and it would hold a value of from this scalar, which would be 41, right? So if I execute this command, it would generate a new variable Rmax, and it would have a value of the maximum value of mileage variable. So we didn't wrote the value 41 directly into the variable, rather we retrieved the value from this scalar, this Rmax scalar. Or we could have performed certain calculations on these scalars. So for example, I want to look at the range. So that range would be equal to the maximum value, the difference between the maximum and the minimum value. So what I can do is I can calculate the difference between R max and R minimum, And this is what I'm doing over here, the difference between R max minus R minimum. This would give me the range of the values, which would be 29. Now how do we know which in which label these values would be stored? Now there are three ways of doing this. One is the method that I've just shown you, which is by using the return list command. We get these values and we can quickly screen them, and we know that R mean would mean that it is the average value, RSD means standard deviation, R minimum, R maximum means minimum and maximum values. But in some cases, let's say sum underscore W, it isn't quite clear what this value would mean. For that, we can go to the help of this summarize command, and the details of all these scalars is at the end of the help file. So it is saying that our sum underscore W is the sum of the weights, right? And then we have Rn, which is the number of the observations. Similarly, R sum is the sum of the variable, the sum of all the values in the variable. The third way is, which I usually do, is I look at the value that I'm interested in. Let's say I'm interested in 21.29. I would quickly screen that value over here, and I know that 21.29 is stored in this R mean scalar. So I can use this scalar to retrieve that value. But again, that method is prone to error, because sometimes, let's say 41, you are getting 41 values for different multiple times. So in that case, which 41 value should you use? Now in this case, should you use Rn or R sum W, because both have the 74 observation. In that case, we can know that Rn is the number of observations. This is if we are interested in number of observations, that we are going to use Rn. Okay. So we can use summarize. So we can use this return list command with multiple, and most of the commands store their results in some kind of a scalar. I'm going to give you two more examples. One is with the summarize detail, and the second would be to use Ttest. So let's first use summarize detail. We are going to have a detailed summary of the mileage variable to get different for example, we needed skewness or kurtosis, or we needed different percentiles, or we were interested in median. So we know that 50th percentile is the median value. We could have to retrieve the list of the scalar. We again can use return list, and we know that RP50 is the scalar that stores the median value, or R skewness is the scalar that stores the skewness value. Okay, so let's move to one more RClass command, which is Ttest. Let's say I wanted to perform a Ttest whether on the price variable, whether the prices of car are same for different categories. For example, I wanted to see whether foreign car and domestic car have similar prices. So statistically, are these prices same or not? So for that, I would use two sample Ttest command in the price name, and by foreign variable, I get this table. Now I know the domestic cars, the mean value of the mean price of the domestic cars is $6,072. Mean price for foreign cars is 6,384, and the difference between the domestic and foreign car is 312. So the difference between the domestic car are 300 rupees cheaper as compared to foreign car. But is this difference statistically significant? We can get that idea from the t value, which from this case we know that it isn't statistically significant. And again, if I wanted to look at how these values are stored, I would use return list. But this time I would be amazed that I cannot find this -312 value over here, right? I have 6070, which is R mu1, the first mean, the mean of the first category, R mu2, the mean of the second category, the second sample, 6384, but I don't get this value, right? Similarly, I am not getting the t value. Now what is happening over here? What Stata is doing is it is storing the unique values, and if some value is to be calculated based on other values, then it wouldn't store that value. For example, in this case, these mean of domestic and foreign car is a unique value. It would store them in this particular scalar, but the difference is created based on the calculation, the difference between these two values. So there is no need to be redundant and store all the values. So rather, Stata would use certain formula to calculate this value, and the same procedure we would have to apply if we wanted to retrieve this value, right? So we know that the mu1 stores the price of the domestic car, and the mu2 stores the price of the foreign car. If we find the difference between them, we can get the value that we are interested in, right, which is the difference of these two samples. Now what if we are interested in the t-stat? So now we know that t-stat would be equal to the difference value, the mean value, the difference mean value, and the standard error. If we divide the mean by standard error, we should get 0.41. Let's find the standard error. We get it from RSE scalar. If I divide the difference mean by this standard error, I should get 0.41, which is the t value. So this is how I usually store the values. If I want to perform certain task on them, I can store them into certain variables, right? So once we have understood the RClass commands, let's move to EClass commands. And the widely used EClass command is the regress command. Now, the EClass, like the RClass, would store the results in R and certain label in the parenthesis. The E would store using the E alphabet, right? So let's execute this regression command. Now to get to know how these values are stored, for the R class we would use a return list, but for the E class we would use E return list. So let's use E return list. Now we get different sections, right? We have scalar, we have macros, we have matrices, and we have functions. So we would first start with scalar, and then we would discuss functions and matrices, but we wouldn't discuss macros. For this case, it is just storing the string values anyways. But we would have, our next video would be on local and global macros. So stay tuned to the channel, and the next video we would discuss macros. Let's start with scalar. Now we know how to retrieve scalar values. Let's say in this case I am interested in R square. Now how do we get R square? Do we have that values in this list? We do not have it. I have quickly searched it. So that means you would have to get this R square value based on certain calculations. How do we get this R square value? The formula is explained sum of square divided by total sum of square. So let's open the help regress file. And let's move to the end of the help menu. Now we are interested in EMSS, which stands for model sum of square or explained sum of square, and then we are interested in residual sum of square. If we add them up, we would get total sum of square. And if we divide the model sum of square by total sum of square, we should get R square value. This is the formula for calculating R square value, right? By the way, although that R square wasn't visible over here, but okay, it was visible, I missed it. But anyhow, I can calculate this based on the scalar R square, right? And this scalar command is storing that value, but it isn't displaying it. So if I wanted to display, I would reference to that specific scalar and it would display the value. Or if I wanted to store them, I could have stored them. Let's move to function. Remember, we had a function section. What this function is doing is it is storing the cases that were used in this regression. Now if you look at the number of observations in this file, there are 74 number of observations in this data. But when you execute regression, we only get 69 observations. This regression was executed on only 69 observations, and the reason is that in Stata the regression is based on case-wise deletion. What case-wise deletion we mean is that the regression would only be executed on the cases or on the individuals, or in this case on the cars, using the data of the cars that for which the whole data is available, the data that the variables that we have used in the regression. So if I move towards the data view, I would quickly notice that for these two cars, there would be some others down below. We do not have the repair, we have a missing value for the repair variable. So these cars for which either mileage or the repair variables data is missing, they would not be included in the regression analysis. So that's why, although we have 74 observations in the data set, but in the regression we only have 69 observations. We have used 69 observations for the regression. So when you are reporting this regression in your research paper, you would also report summary statistics, most probably, a summary of the variables. So rather than reporting summary of all these 74 cases, all these 74 cars, we only want to report the summary statistics for these 69 cars, the cars that were used in this regression, the cases that were used in this regression. So we can use sum if e sample, we are referring to this function, is equal to 1. So now you would see that we get the summary statistics of all the variables, but we only have 69 observations because we have only used the observations, the cases that were used in previous regression. Or what I could have done is I could have generated a variable called sample, and that would be equal to 1 if that case was used in the regression and 0 if it wasn't. So let's see how it looks like. We would see that we have a value of 1 in this newly generated variable, where both variable didn't have any missing value, but in this case there is a 0 value because this specific case, this specific car was not used in the data, was not used in the regression, so it would have a value of 0. Okay, so once we have understood the scalar and the functions, so let's move to a difficult part, which is matrices. So before I move forward, let me re-execute this regression so we have the results nearby so we can quickly reference them. Okay, now I want to see what there are two matrices. One is the EB and the second is the EV. This EB matrix stores the coefficients. It is a rather vector, a row vector. We have one row and 3 columns, so it stores the coefficients or the intercept values from the previous regression, right? Whereas this EV is the variance covariance matrix, right? It would store the variances and the covariances of different variables used in the regression. But let's first look at how do we retrieve the coefficient values from the matrices. So I'm going to first list the matrix and see what is stored in that matrix. I would use matrix list and then the name of the matrix. So we have this so we have this list of the matrix. It is a 1 into 3. We have 1 row and 3 columns. The mileage variable had a coefficient of -271. The repair variable had a coefficient of 666, and the constant was 9657. Now, although I get the list, but if I wanted to retrieve a specific value, then what I would do is I would reference to that specific row and column. So first I would use the name of the matrix, then the row and the column where the value is stored. So in this case, I'm interested in the coefficient of the mileage variable. So I would write the name of the matrix. I know it is in the first row and the first column, so that would be 1 1. I would display this and we get -271. If I wanted to store that value into a scalar or any variable, then I would use scalar, the name of the scalar, and again reference to that specific row and column of the matrix, and it would be stored. Similarly, I want to have the coefficient and as well as standard error, but you know the standard error is displayed over here, but in the list, in the e-return list, we do not have any standard error, though we have variance covariance matrix. And we need standard error because we need to calculate a t-value, and the t-value would be equal to coefficient divided by standard errors. So let's first see what is in the variance covariance matrix. So matrix list and the name of the variance covariance matrix. This is the matrix. It is a 3 by 3. We have 3 columns and 3 rows. On the diagonal end, we have the variances of each variables, and the other values are the covariances. So we are interested in the standard error, and we know standard error would be the square root of the variance. So I want to have the square root of, I want to have the standard error of the mileage variable, so I would use square root function and reference to the EV because the mileage is in the variance of the mileage is in the first row and first column, so I would reference over there, right? And it would give me the standard error, which is 57.71, and it is the exactly same standard error that we get over here. So now I can simply divide the coefficient with the standard error to get t-value. So I am giving the reference of the beta, the coefficient, and the standard error, and we get 4.72 t-value. But again, this is a difficult way of getting value. So let's say somehow you change the sequence of the variables in this regression. Rather than mileage being used as first independent variable, it is used as a second independent variable. So in that case, the order of these variables in this matrix would also change, and if you execute, there might be an error, right? You might accidentally get a value of different variable rather than the variable that you wanted. So there is a simple and more error prone way of getting these coefficients and the standard errors, and that is to use _b and the name of the variable. So in this case, if I use _b, this _b stands for the coefficient or the beta, and then the name of the variable in the bracket, I get the coefficient of the mileage variable. Similarly, if I wanted the constant, so I would use _constant, and I get the intercept value, right? I can also use these values to get to calculate the estimated value. So let's say if I want to get the estimated value price of the car, if the mileage variable had a value of 20 and the repair variable had a value of 3, then I would use this equation and I can get an estimated value that a car having a mileage of 20 and a repair of 3 would have a price of estimated price of 6,200. Similarly, we can reference the standard errors by using similar method, but instead of _b would use _se. So we get standard error, which is 57, the same as we got previously, and we can divide these two to get the t value. We can store this value or perform certain tasks. There is one last thing that I would like to discuss. After executing the regression command, we can, if we use return list, we get these matrix and this scalar. This matrix is a 9 by 3 matrix and stores certain values. Now what is it storing? Let's look at it. Okay, so a huge table, and it stores all the values, the coefficients, the standard errors, the t values, the p values, and whatnot. So we can also reference to this table, this matrix, and get the value that we want. So let's say if we wanted the t value, we could have used display the matrix name, and because we know the t value of the mileage is in the third row and the first column, then that would be 3, 1, and we can quickly get the t value. But again, this would obviously have the same issues that we had with the accessing of the matrix method. But you would also think that if we can to extract the coefficient, we use _b, to extract standard error we use _se, then shouldn't we use _t to extract t value? And that's what I thought, but somehow that do not work, right? Thanks for watching this video. In our next video, we are going to look at local and global macros, and we are going to see how that can become useful in our analysis. Do hit the subscribe button and the like button. Thanks for watching the video.